Check 1, 2, 3. Okay, so we're back again in the chemistry lesson. Now we're going to continue the discussion on chapter 9. About the metal. The topic that we're going to discuss today is about the uses of metal. Okay. The core principle is this. Okay. Suitability of properties is going to determine their uses. If it's suitable for a particular job, we're going to use that metal. That's the idea. Now, because of them here, we're going to see what is the properties we need for a particular application. Then we can find out the metal that is possessing that properties that's going to do the job. Okay, so what is the most common need of metal? Usually, most application require us to think it's going to be strong, but it's going to be also be relatively cheap. Both of them, strength and cheapness, that's going to be the major requirement, led us to the use of the most widely used metal of all, steel, which is a special alloy of iron. That is the reason why steel is the most manufactured metal in the world. We don't call them iron because in chemistry, iron means the pure iron. Okay. We call steel ferrous, means it's containing iron, but steel itself is a special class of substance. Okay. Okay, now this is in the general rule. Whenever you can use steel, you use steel. Almost always because of the strength and the cheapness of it. Okay. Practically, all of the elements is going to be more expensive than steel. But still, if there are some other properties that is better suited for the metal, we are going to use them instead of steel. What are them? Okay, let's talk about them here. Okay, use number 1 here when we want to use aircraft. Now, what are the properties that we want to be in an aircraft? Okay. Generally, it needs to be strong enough, okay? Just strong enough to hold the ship. The aircraft is not like a bridge who has to withstand a lot of masses other than itself. Okay? But we want it to be lightweight. Well, we can something that's lightweight if it is low density. Okay. And also, we want an aircraft to be generally resistant to corrosion. Corrosion means reaction with oxygen. Okay. The cheapness is not that important in aircraft. We are willing to pay for a substance that is more expensive, but lightweight, but still strong enough. Okay. Because we are going to use aircraft for many, many years. Commercial aircrafts nowadays was designed to last about 30 years. Okay. Old aircrafts actually last longer. There are some aircraft from the World War II that's still airworthy. So what is this element that's going to possess these two? Well, it's usually going to be aluminum. It's lower density. the density is less than half of the steel, and it's going to be resistant to corrosions. Ask yourself, would you willing to make an aircraft that is strong, but you can see corrosion, rust here and there? I don't think so. Okay, so that is the first application. Okay. Other mode of transportations, they don't value lightweight as much, such as like train, ship, or cars or trucks. Okay. On those type of transportation here, we don't need to it to be very lightweight, okay, because it can withstand on its own. It's more important for it to be cheap because we are going to make them big. Okay, next, number 2, it's going to be an electrical cable. Okay. Now, in this case here, we need to know about 2 types of electrical cables. Okay. The one that is used for low electricity, okay, means low voltage, low amperage. They don't transmit lots of electricity. In this case, what we want them is to be lightweight. Okay. But more important, generally, when we want to have wiring, we want them to be flexible. Because of the ability to transfer electricity, because the electricity to be transferred is low, we don't need a lot of conducting material. So the price is not really a concern here. It is better to have something that is more expensive, but they are flexible in this case. Okay, flexible, or we can also call them, so flexible here, they're going to also be ductile. So we can make them into small wire, but long. Okay. In cabling, we don't need to big one. Sometimes you just need, if you take the cables here, the cables can be less than 1 millimeter thick, but they can run in, sometimes they can run miles and miles. So we need something that's ductile. We can draw them into thin but long wires. Okay, they are going to they're going to have good conductivity of electricity. And who are the winner here? Okay, the one that possess all of them here. The price is not really that important. It's going to be copper. Being one of the noble metals, copper is soft. Pure copper is seldom used as constructive material because of its softness. Copper is generally dense, yes, but in wiring, we need so small of them, so few of them, that the weight is usually not a prime factor. Sometimes, actually, the insulators around the wire is going to be heavier than the wire itself. Copper is also being ductile. It makes them flexible. Imagine if you have wire that is stiff, you will be able to rearrange your equipment, and you will not be able to put in the charging cables easily. Okay, now, but there are a second type of electric cable here, the one that is used in high electricity. high electricity, high voltage, high amperage. In this case, okay, we are going to transmit electricity in a large amount and going long distances. Means we're going to cut them here in overhead power cable. Why don't we put them underground? It's because of ability of electricity to be conducted in nearby substances. If you put them near enough with the ground, then the electricity can jump from the cable to the ground. We're going to lose it. We put them high up in the air, it's because the air is going to act as a conductor. So much electricity flowing in them that actually we need to have a lot of insulator. The best insulator we can have is vacuum. Second of that will be the air. Any substances, even plastics or wood, actually less able to do insulation than vacuum or air. Okay, so overhead power cable needs to be up there. And we're going to have them in long distances, means we need them to be lightweight. Lightweight, but still good conductor. So how can we get something that is lightweight? By hitting something with low density, just like the case with the aircraft. Again, this one, the winner is going to be aluminum. So the aluminum power cable the power cable that we see up there in the air, they're actually not made up of copper as we usually see in daily life. They're made up of aluminum. Okay. Of course, aluminum itself is not that strong. So what we're going to see is they're going to have the core made up of steel. Okay. And outside of them, then we have the aluminum, which is going to do the actual conduction of electricity. Overhead power cables is actually not being insulated using rubber or something. It's bare. That's why don't touch them. Okay, so that's about the overhead power cable. The last one that we're going to discuss here is about the food container. So what are the properties we want from a food container? We are going to, the most important thing, it's going to be resistant to corrosion. You don't want your food to be stained with corroded metal, be it in dissolving or in a solid condition here, and then you're going to digest that metal. You don't want. We don't need something that is very strong here. We don't need something that is lightweight or something here. And because the food container is usually going to be, the food that we're going to wrap is usually not going to be demanding. It's not going to be heavy. We can have something that is thin and not that strong. But still, the first one is resistant to corrosion. That is the overall one. If it is a little bit expensive, fine. That's why a lot of food containers made up of plastic because of resistance to corrosion. But when things require us to use metal, again, this is still aluminum. So with so many applications in different areas, small wonder that aluminum is the second most produced metal in the world, second to steel. Copper, yes, okay, that's going to be used a lot because of the electricity, okay, but the clear runner-up is aluminum. Okay. Again, we're going to see the concept. The concept is the suitability of property. What you use is going to tell what property you want from a substance. Then from this, we're going to choose the substance. This is the logic. What do you want it to be used? What properties that is needed to do that job? Hence, which substance can do that job? With this, you can see, you can understand the choice that we make for certain substance. But what if there is no substance that is fulfilling the required properties? Then we make a new one. That's actually the reason why we invent plastics back in near World War II. Okay, so to make things short here, okay, the metal we need to use to manufacture aircraft is aluminum due to its lightweight. The substance we need to electrical cables, if it is low electricity, it's going to be copper wiring. And if it's high electricity, we're going to use aluminum for overhead power cables. For food containers, we're going to use the aluminum again, okay, because it's resistant to corrosions, be it in aluminum foil or aluminum cans for drink. We're going to use aluminum for food containers. Okay. All of that under the logic, use is going to dictate properties, and that properties is going to dictate which substance we use. That will be it for today. Thank you very much. See you later.